Hello. Good afternoon, Amma.
Good afternoon, sir.
Today we are discussing methods of electric heating. So different methods are there to heat the whatever the material, whatever the functionality. Different electrical methods like mechanical heating. So how to can heat whatever the material or whatever the product or whatever, then what are the functionality like. So what are the methods is direct resistance heating, indirect resistance heating. So yeah, generally based on that, what is direct resistance heating? What is indirect resistance heating? Indirect resistance heating means current is passed through a charge or substance to be heated, like electric boiler, electrode boiler. So this principle in like electrode boiler. So current is passed through a substance automatically to be heated. It produces the heat. That is direct resistance heating. So is why name called a direct resistance? It means a substance means a conductor. Conductor it has a resistance. Conductor it has a resistance. So conductor it act as a resistive material. So it means that when current passes through a substance, automatically to be heat the whatever the substance, then it produces the heat. This process we call as direct resistance heating. And second one is indirect resistance heating. In this indirect resistance heating, when electric current pass through a wire or high resistance heating element, heat so as developed transferred to charge from the heating element by convection or radiation. So last class, conduction, convection, radiation process are already I discussed three processes. So by convention or radiation process, energy is transferred to charge from heating element. For heating the generally electric heater, when current is passed through a heater, that whatever the heat is by whatever the process, either radiation process or convection or conduction process, heat is transferred to water. Then automatically the water is heated. So indirectly, we are giving supply to the resistive coil. Indirectly to energy that whatever the heat is transferred to some other material or some other product. So this process we call it as indirect resistance heating. Indirect resistance heating. So this method you have heating and immerse in water heater. That is example of indirect resistance heating. So next one more thing is infrared or radiant heating. So in this method, heat energy is transferred from source like incandescent lamp, focused upon the body to be heated up in the form of electromagnetic radiations. Normally, this method is used drying clothes or textile industry and dry wet paints an object. Then if it switch on the light incandescent lamp, then surrounding that whatever the lamp or lighting area to be heated. The position is heated. Like go for for poultry farms also. Then night times, then what in some winter areas, the most of the times then switch on the lights. Then it produces the heat. Then automatically in the winter season, then it maintains the temperature. It maintains the temperature. Somewhat it gives some certain temperature. Then automatically the poultry farm, whatever the poultry, whatever the products, whatever then somewhat it produces the heat. Then automatically somewhat in good condition, temperature will increase in poultry farm. This is also this process infrared radiant heating. Next one more type is direct arc heating. Direct. So in this method, direct arc heating case, striking the arc between charge and electrode or electrodes. Means then what arc produce strike when I have to give to the supply to the arc, then it comes a positive electrode and negative electrode. Then the heat so then automatically when the arc is heated means it developed and directly connected taken by the charge. So furnace operating on the principle of direct arc furnaces. Then the arc furnaces this is under the direct arc heating. So main application of this type of heating is production of steel. Steel production purpose we are using direct arc heating process. Next indirect arc heating is so arc is established between the two electrodes. So heat is then whatever the heat is so developed is transferred to charge or substance by radiation process. So these are generally non-ferrous materials used melting of non-ferrous. Example application of this indirect arc heating, indirectly transfer the energy like the indirect resistance heating. Here radiation process to transfer the energy or transfer the heat. So example is melting of non-ferrous material metals. And next one more type is direct induction heating. So in this method, direct induction heating, currents are induced by electromagnetic action, the charge to be heated. The induced currents are used to melt the charge of induction furnaces. The example is induction furnaces. So electromagnetic induction process, the indirect induction heating. Indirect means then indirectly that energy is whatever the heating element is transferred of body to charge some other material by radiation or convection. So not indirect. Indirect means, what is the difference between indirect and direct? Means directly to give the energy. So indirect induction process, same electromagnetic induction, whatever the heat or whatever produced here, this is transferred to some other body by the radiation or convection process. This process we call as indirect induction heating. So generally induction furnaces used for heat treatment of metals. So then also metals heating purpose also we are using indirect induction heating process. Next, one more type is dielectric heating. So this method is heat developed of non-metallic material like dielectric materials. The friction the non-metallic materials like dielectric materials. So heat is produced here. The preheating of plastic performs breaking foundry cores, baking foundry cores. These are the applications of dielectric heating. Another what is resistance heating? Already I discussed direct resistance heating and indirect resistance heating. Infrared or radiant heating. Direct resistance heating, this is the simple diagram for example or application of direct resistance heating case. Here, see here, two electrodes here, electrodes as a positive and negative electrode. We are giving the supply to in between two electrodes. See the high resistive powder. It is charge particles here. When here electrodes are immersed in a material or charged to be heated, then means when it gives the supply, means then automatically electrodes are heated. Then whatever the here inside what here we are giving AC supply or DC supply, both they are available here. And nowadays both AC and DC supply direct resistance heating equipments are available. When you have to heat what is powder, whatever is then resistive material to be heated, then the resistive material produces the heat. Like your laboratory resistance, when you supply to the resistance, certain time period resistance to be heated. When you touch the resistance and the heat somewhat, then to heat produced. That heat based on that, here also same process involved here, direct process. Then one example of this direct resistance heating. One more, salt bath furnace. Next, electrode boiler. These are the examples. Like this is electrode boiler. Electrode boiler, ready to three-phase supply. Next, indirect resistance case. So see here. Here this is substance. When this heat is a one separate chamber. When you are given to supply, the chamber is heated. So by convection process, so this heat is transferred to this, then automatically here. So we are given to supply to the AC. For example, air conditioner. We are given to the supply to the air conditioner. Air conditioner is cooled or whatever. Give the whatever the coolness of total throughout room. So indirect by convection process or conduction or radiation process, transfer the coolness in by electric air conditioner, the AC. But similar here also, indirect resistance heating, like resistance ovens, like temperature increases ovens. Most of the in agriculture cases we are using this this ovens, resistance ovens. So what is the process here? The heat, whatever the here based on the according to from heating concept, heat of that what is the oven by using this ms into delta t into j. Joules means here what is m is mass of refractor whatever the material we are using, and s is the specific heat, and delta t is the rise in temperature. What is the starting temperature? Then what is the ending temperature? Difference between the rise in temperature. So here based on this ms delta t by using h, how much of heat is produced here in whatever this indirect resistance heating case. Then efficiency, we allow that the heat required to raise the temperature of the charge divided by heat required to raise the temperature of the charge plus total losses. Generally resistance ovens are efficiency is in between 60 to 80, not more than 80. So automatically then 20% of efficiency will lost due to this whatever the case if you are heating indirect resistance heating case. So not in not more than that, not in 80, less than 70 only. Somewhat some few cases it reaches to 80%. 80%. Next, what about another type is the infrared radiant heating. Then here infrared radiant heating. So already heat transferred, then to source the body heated by radiation process. Then medium temp, then the low and medium temperature applications we are using this infrared radiant heating case. Then one more important thing is temperature resistance controlling. Then how to temperature resistance the controlling is by based on using the material, whatever the resistance of material, it can increase or decrease the temperature, and that is also possibility in here and whatever means by this heating process. Next, one more type is arc heating case. Arc heating case here generally uh, arc process are involved here. When if you are given to supply to the two electrodes, either positive or whatever the, if you are using whatever the material, the carbon or graphite material, if you are using here arc, then what are the silent features other than this other materials like aluminum, ferrous alloys, phosphorus, aluminum, phosphorus? Silent features of carbon graphite are: one is resistivity. Graphite electrodes have low specific resistance than carbon electrodes. That's the difference. Carbon compared with carbon electrodes, specific resistance is low of than what is graphite. And one more thing, oxidation graphite begins oxides at 600 degrees, whereas carbon is 400 degrees. Another consumption, steel melting furnaces, if you are in carbon electrodes, 4.5 kg of electrodes per ton of steel, and 2.3 to 6.8 kg electrodes per ton of steel of graphite electrodes. Then compare with here 2.3, then at a low level case, then at a graphite is good material, good arc furnaces. Then have to go for some cases, then carbon arc furnaces. Sometimes we are using for steel melting purpose. We are using this arc heating. Mainly arc heating is steel melting purpose. Then cost based graphite will cost about twice as much kg per kg as than carbon. Graphite cost is more compared with carbon electrodes. Then well already I discussed direct or indirect arc furnaces. Direct furnace is like this directly, or indirect same process here, direct or indirect. Then indirect case, then auto heat is transferred, then a first electrode heated, this radiation process, then to transfer the heat to then whatever the substance or material, radiation process. That is the difference. Next, one more type is high frequency heating. So generally, so what is the main difference between power frequency and high frequency heating is that, so by the conventional methods, heat is transferred either by conduction, convection, or by radiation. High frequency heating methods, electromagnetic energy converted into heat energy inside the material. Then if you are given to the supply, so here in this case, induction, the high frequency heating means that is one type of induction heating. So we are given to the supply to the whatever the material, then here material is heated, produces the flux. That flux is created by the it creates the electromagnetic field. So electromagnetic field it creates in the process electromagnetic induction process, it creates electromagnetic field. Then automatically that electromagnetic field, that flux is linked with other part. Then automatically the flux is linked with other part. This heat is whatever the production of this material, it transferred to by a radiation process or convection process, transferred to some other material. So this process involved in the high frequency heating. Under the high frequency heating, induction heating, so generally power drawn, then value that electric process, then V square by R, where the R is the resistance of the material. So this is the process, copper coil. When you have to go into the supply to the copper coil, coil is heated, creates a surrounding the coil, it produces the flux. This flux created with electromagnetic field, and this electromagnetic field then when this heat is transferred to some other material. So mainly, so materials were copper, aluminum material we are using here. So under that, whatever the here depth induction heating case, depth of penetration, this concept already I studied in physics concept and electric machines one subject. So depth of penetration of induced currents of any circular disk, d equal to 1 by 2 pi square root of rho into 10 to the power of 9 by mu into f, mu into f. From you, if you are seeing here, D is inversely proportional to square root of 1 by mu f, or directly proportional to raw density of material. Generally, there are two different types of there here. Core type furnaces. I generally operating the transform furnace, the direct core type, vertical core type, indirect core type are different are there. Direct core type induction furnace is like this: primary and secondary. If you are going to supply primary, then a transferred heat water in the secondary case. Direct core type furnaces. Then indirect case, if you are seeing here, so then over vectorial core type index like this. So vectorial shape. So chamber same, if you are going to supply primary, then go for secondary, you have to transfer here. Vectorial core type induction furnaces. Then compare with direct or vector, compare with vectorial, the current temperature control, metal loss is reduced. Next, one more thing is operating of high power factor compared with the core type. The pinch effect can be avoided. This pinch effect means then this is also one type of loss present in then what these furnaces. The next indirect core type is like this here: primary winding and secondary winding. Indirectly, when I do this transfer, then bed is heated through this bed is heated, then automatically this energy is transferred via bed material. That is indirect process, indirect core type furnaces. Like this, it's also core type furnaces. Then coreless type also induction furnace also available. So then it's not present in core here. Directly when container, so charging particles, then I have to directly we have to go without core. Next, go for dielectric material, dielectric heating. Here, what are the dielectric material? Non-metallic materials charging here: wood, plastic, china glass, or then non-metallic materials charging here. Then, if you are giving supply connected to the dielectric material is heated and transfer the energy. So, based on this, the value of that concept of dipole moment is an electromagnetic field theory. P dipole moment is equal to Q into D. So, V is the distance between the plates, Q is the charge, where at a distance between them increases or based on changing the dipole moment value change. When rising the electric dipole moment, then to transferred, then what is the electrical energy transferred by the electric material to some other whatever the charge particle, then heat like this. See here, it's a dielectric material. Then electrodes are very good supply here, directly heated energy is transferred to some other material. So when internally, then how to represent this equivalent circuit diagram, where given voltage supply connected to the dielectric material, resistance and capacitance are in parallel, IR and IC, when I equal to IR plus IC. So based on that, summation of this IR, vectorial summation of IR plus IC equal to total current flowing through the circuit. So here compare with furnaces like direct or resistance furnaces, arc furnaces. Dielectric heating is somewhat is good. Rapid conduction, or means uniform heating material is possible here. Heat is produced in whole mass of the material. The wastage is very less, loss also very less here. So voltage generally you have to maintain voltage gradient is 18 kV per centimeter. The dielectric heating, the range of frequency is 1 to 40. Say high frequency range here possible here. And application is drying of paper, gluing of wood, heat sealing of plastic sheets. Then we have to next to go for here home appliances, doors pressing purpose also dielectric heating. And dehydration of milk, cream, vegetables, preparation of thermoplastic resins, heating of bowls and tissues, dielectric process. Diathermy and sterilization of absorption of cotton, bandages, processing of rubber, synthetic materials and chemicals. These are the applications of dielectric heating. So today's class we were discussed regarding different types of heating methods for resistance heating, direct arc, indirect resistance heating, direct resistance heating, direct arc heating, and indirect arc heating, induction heating, direct induction heating, indirect induction heating, and one more type is dielectric heating. These are the different types of heating methods. Different applications are there here. What type of questions are asking for this unit is short answer type or long answer type? So advantage of electric heating. What are the advantages of electric heating? And compare with then other heating methods, electric heating is losses are very less and cheaper cost. These are the one more thing, electric heating the equipment cheaper, does not require skilled persons, and temperature to be controlled regular by manually or automatically. And next one more type is what are the modes of transfer heat? Conduction, convection, radiation. Already I discussed. What is an oven? And define conduction, define convection, radiation definitions. These type of questions, answers are there here. What is Stephen formula? Short answer questions. What is meant by resistance heating? What is meant by arc dielectric heating? What is meant by induction heating? What type of process are what is heating process are there in induction heating? Heating process are there in dielectric heating, and applications of dielectric heating. These type of questions are asking uh, external exam and short answer questions. Then what is pinch effect? So a pinch effect is the formation of bubbles and voids in the charge to be heated by electromagnetic induction. This process is involved in induction heating due to the high electromagnetic forces, which causes interruption of secondary circuit. This effect we call it as pinch effect. It's about different short answer questions related to heating process. Next class we'll discuss welding types. Okay, ma. Thank you.